Sir, my major project title is Image Fusion with CT and MRI image for improving the quality of diagnostic. And we are taking from the guidance of Jivanantham sir. And this is our main agenda. In agenda, there is abstract. The most common technique for image fusion is DWT wavelet. We in this fusion relation image will have the information like horizontal, vertical, and diagonal directions. And this direct wavelet transfers has two shortcomings. One is shift variance, and another one is directionality. To shift variance will lead to errors and in fused images. Due to some, the source image will become difficult for processing, and the DW will provide a better diagnostic and the shift variance, which is easy to process the edges and contents of the source. And main aim of the project is to obtain the fusion image combining CT and MR image. And another important aim is to obtain the superior exit image will that provide accurate and reliable statistics that may single image while returning the best functions. And scope of the project is the main scope of the project is uh, fusion of multimodality image plays an important role in the medical imaging field and the clinical issue of various medical imaging systems. Different medical imaging technique may provide scans with complementary and occasionally reduced information. The main scope of the project is to develop an efficient fusion technique to fuse single or multimodal images using geometry complex wavelet transfer and introduction. Main magnetic reasoning image MRI and computer tomography CT medical images will not provide as much as detailed information in that medical based research and diagnosis what we researched in that, and they require to provide a lot of elaborated clinical data, and in medical imaging and system will provide the different medical information regarding tissues. And for example, X-rays are used to identify the bone injuries and bone fractures. CT images will give the elaborated information of internal organs, tumors, and blood vessels. And all these features will not be gathered from a single image or in order to extract all the complete information from a single. We are fusing the medical image or single or different systems. And this is the literature review. And these are the designs and models. There are three modules. Module one collection of data, and module two is data processing, and module three is getting output. In module one, in this module, we have developed a website in which will prompt that user to upload a CT and MRI image in that patient. In that patient, then the CT and MRI image will be in the size of 512 into 512, and also we need to we we need to we need to give the input in as the maximum coordinate to fix the coordinate in the upload source image for in the process of fusion. And step 2 for data processing. After decomposition, we will extract the high intensity and low intensity image, each level in the image segmented into sub bands at 6 directions. And image principal components analysis is used to reduce dimensions of the data, and the PCA will remove unwanted and repeated information present in DTCW format. And this PCA analysis have several steps. The first is standardization, and the objective of this step is to standardize the range of the continuous initial variables. And in step 3, the next step is compute convergence matrix. Some variables are high correlated and with the other variables such a way that they contain redundant information. Hence, the compute convergence matrix to find the correction feature, and finally, the reconstruct the data with the principal axis and the getting output. The extract coefficient of experiment. Finally, we get the approximate wavelength coefficients, and then our image was the fusion and approximate coefficient fusion to get fused coefficients. And now apply the dual tree complex wavelet transfer and to restore the fused image. And these are the standard and policies. This is our implementation. Implementation for test care are used. A test case is a set of action performed on a system to determine if it is satisfies or software requirements and functions correctly. The purpose of a test case is determine if different feature with an system and performing as accepted and confirmed that the system satisfies all related standards. And a test case or document includes the test steps and test data, predications and post conditions and the verification requirements. And this is our architecture diagram, CT and MRI image. This is our data flow diagram. Next, this is our use case diagram. This is our class diagram. Next, activity diagram, and next sequence diagram, and next ER diagram. And there are 5 types of testing is there: unit testing and functional testing, white box testing, black box testing. In unit testing, the test system's ability to accurately align and recreate the MRI image and CT image to ensure proper fusion. The test the system ability to handle different image and resolution sizes. And in the integration testing, the test system's ability to perform accurate image registrations and fusion, ensuring that resulting image provides. And in the functional testing, test the systems able to handle different image resolution and sizes and ensure that the fused image is not distorted and or blurred. And they test the systems able to handle the different type of pathology such as tumors, lesions and hemorrhages and ensure that the fused image accurately represents the extent and location of the pathology. White box testing. There is nothing in white box testing. This testable the image fusion process to preserve important features in the MRI and CT scans, such as regions of tumors and brain tumors. And black box testing test the system ability to handle noisy and corporated image, such as those affected by motion, air traps, and metallic implements or patient motion. Test the system's ability to handle the different contrast agents, such as gadolinium-based contrast and agent MRI and iodine-based contrast agent CT scans. And this is our input MRI image and CT image. And next when we do coding, and this is our image fusion model, and this is our final output image segmentation model. In the finally conclusion, medical images are used for diagnosis and the diseases are helpful to treatment. The dual tree complex wavelet transfer based fusion will compute the fused multimodal image, which show good selective and directionality and better shift variance. In magnetic reasoning image and decompose them with DTCW2 means direct wavelength transfer, future extraction of coefficient and approximation of extracted coefficients are performed. And hence the fused image of our proposed scheme exhibits more defined edges, tissues, spectral contour and spatial tissues and tumors. And future enhancements are one area of future enhancement is the help of deep learning algorithm for image fusion. Deep learning algorithm each can learn the relationship between different modalities and fused images based on the learned features. This can improve accuracy and efficiency of the image fusion process, leading to better diagnosis accuracy. And another area of future enhancement is developed to real-time image fusion technique. Real-time image fusion can be particularly useful in situations where rapid decision making is critical, such as during surgical procedures. And by providing real-time fused image, doctors can make more accurate and informed decisions. And this is our reference. And the code was, this is our source code. Image segmentation code, this is one. And next transfer learning code. This is the whole and app.py code. And next this is app.py code. And this is our poster presentation. This is our poster presentation. And next what we have to do. And now I am trying to get output. Type python space app.py This is our output. Now we can copy the URL and paste it some Chrome like paste your URL. And here select a MRI image and CT image, and now we are selecting one MRI image and patient data. This is MRI image, and next select CT image and give one number of maximum 5 to 10 middle. I'm giving 6. When we are giving 6, we have to type 6 times here in each image. 3, 4, 5, 6, and next CT image also 1, 2, 3, 4, 5, 6. Now submit the data. Now this is our registered MRI image and registered as CT image, and now the fielded image will come. This is our the fielded image, and now next we the segmentation image. This is our final output, that is image format segmentation. This is our final input. Completed. Thank you.